Welcome to March 17th LeetCode Challenge. Score of parentheses. Given a balanced parentheses string S, return the score of the string. The score of a balanced parentheses string is based on the following rule. Open parentheses, close parentheses has a score of 1. A, B has a score of A plus B, where A and B are balanced parentheses string. Open bracket, A and bracket has a score of 2A, 2 times A, where A is a balanced parentheses string. So these are the rules we have to follow. If we have S equals the first rule, then the score is 1. If we have nested parentheses that are valid, then the score is 2. And we have two parentheses side by side, pairs of parentheses side by side, I should say. The score is also 2 as well. The length of S is between 2 to 50. S consists of only open brackets and closed bracket. And S is the balanced parentheses string. So you both know there's two things that the constraints kind of state. That the string itself contains of open and closed parentheses. The length is between 2 to 50. And the string is balanced parentheses, so that means that every open bracket has a closed bracket, potentially. And that this A and B here just means that the score are the parentheses scores. So at the end of the day, it all reduces down to finding this right here and applying the math to it. So to do this, we can use a stack. So let's see, for every position in the string has a depth of some order matching the parentheses surrounding it. So for example, let's say we have the following. We have, oh man, that's gonna do it by itself. We have this following, right? Dot, open parentheses, close parentheses, and there. So this means that the dot inside here just kind of denotes that it has a depth of 2. So we have 1 bracket, 2 brackets. So therefore it's within 2 nested parentheses because of the 2 parentheses. So, I mean, if we were to say, yeah, if you can't see it, maybe I'll just kind of type it out. It'll look something like this. Dot, something like that. See, we have 2 parentheses within the parentheses, therefore it satisfies this equation here, this example here. So our goal is to maintain the score of the current depth that we're on, and when we see an opening bracket, we increase our depth. So our score of the new depth is going to be 0. So when we close the bracket, we add twice the score of the deeper part, except for when we're counting the open and closed parentheses, which has a score of 1. So note that everything inside the bracket has 2 times A. So each depth we go in, we have to calculate it by 2. So let's say, for example, we have the following. Something like this. So we have the following parentheses set, right? The score parentheses. So let's kind of go through this kind of visually. So the first one is that we have, after the first parsing, so we look at the first parentheses, we have the stack as such, containing 0, 0. So this is after the first parsing of this character here. So let's put a space there, we've calculated that. And then after the next one, right here, we have the following. We have a bracket that contains, stack that contains 0, 0, 0, 0, 0. Right. So we know that this is like parentheses before, this is parentheses after, and then we reach a closing parentheses. So we know that the point has to be added to the second stack point right here. Alright, now this is calculated, it's done with. Let's just put a space there. And after this parentheses right here, we're closing our second layer, right? This is the second layer, that's the thing inside. We reach to our next one, which is the next opening bracket again. So therefore we have to add a point to the third inner layer. So say we have 1, 0 after that, and then we have another layer here, so that will be adding our fourth depth to it as well. And then after that, we have the closing bracket, which will bring it back to the stack containing 1, 1. After this parentheses, we end up another one containing. So we have to apply the 2 times multiplication here and the addition as well. So it'll become 0, 0, 3. And after our last bracket here, we would have to multiply by 2. Therefore, we get 6. And our output is going to be 6. Alright, let's kind of put that into action. So the first thing we want to do is define the score of the current frames or stack we have. So we'll call it stack, and it's containing 0 to begin with. For each element in our string S, let's say for each index, I guess, in S, the string S, if the index is equal to an opening parentheses, then we want to append it to our stack at index 0. Else, if it's not a closing parentheses, that means it's an open parentheses. Therefore, we want to take we're going to pop it from the stack, but we want to assign that to be this character here. So whatever's inside has to be a point. We're going to call this I don't know, we're going to make a name for this. Let's call it twice, maybe. Yeah, call it twice. And that's going to be stack.pop. And then we're going to update the last index of the stack to be, or to increment, I should say, the following rule. So it will be 2 times twice and 1. And then at the end of this, what we want to do, as before, we want to pop off the stack once this, which sums all the points the scores we have in the system. So it'll be stack pop. The reason why we do that, let's just call this score. So we have to pop it off, but we also have to add the score, which is this following here as well. So we have to follow these 2 rules, combine these 2 rules in this line right here. Alright, let's see if this works. So let's see, stack. Oh, it has to be the max between those 2. Alright. Awesome. There you go. So time complexity wise is big O of n, where n is the length of the string S. Space complexity is big O of n as well, where n is the size of the stack. Alright, that's it guys. Have a great day.